Alright, if we are dealing with electric force and we're dealing with electric charge, which I'll symbolize with a Q, and we actually have two charges. Now this is going back to the situation where we had two pieces of tape, and if we wanted to oversimplify the situation, we would have our charge 1 and our charge 2. Obviously there's gazillions of them along the edge of that tape, and they exert forces. And so in the case of repulsive forces, charge 1 would feel an electric force of repulsion from 2, so it would be the electric force of 2 on 1, and then the opposite would be true. We'd have the electric force of 1 on 2 going the other way, and it would produce between these two places a distance. Alright, and we would call this distance here, well, we could call that one R1 to 2, and it would be a vector, and we could call that one R2 to 1, if you will. That would be a vector. And so that would prompt us to continue on. And of course we're doing the standard issue lawmaking scheme where we write out identities for the things that we're paying attention to. And the important next phase is to try to determine what's dependent, what's independent. And probably the best way to take a look at that is to realize that through our experimentation we noticed that force was directly proportional to charge, and that force was inversely proportional to distance, the separation distance. And so if we combine that into one statement of proportionality, we would have force is directly proportional to charge but inversely proportional to the distance, the separation distance. So here we have our direct variation, and in this case we have an inverse variation, so we could just call this direct variation or proportionality, and that would be our inverse variation. And of course that leaves you with something that is what you would call in algebra class a joint variation. And this joint variation, it tells us that force is dependent and charge and distance are independent, which is an important distinction for what we need to do. And so we'll take a look here and start looking at how do we go about formulating that. So in our lawmaking scheme we always take the dependent variable and we apply all of the need to keep that straight, the fancy forms of 1. And so if you recall from all of our other lawmaking adventures, we always take the independent identities and turn them into fancy forms of 1, which is really just a quotient form of the identity. And so we have all of these factors here. But what we want to do is take notice of what is in direct proportionality with force. And so we know that charge is in direct proportionality with the force value, and we know that distance is in direct or inverse proportionality to the force. And so if we're going to bundle these up together, force is going to be connected to those things jointly, all right? And that would prompt us to do some rearranging. And so force would be equal to, so we're going to have some stuff to put here and some stuff to put there. So I'm going to put the two charges together there and the two distances together there. And everything else stays in its position as far as the quotients go, fractions, whatever you want to call them. And what we have here, this right here, is our interaction variables. Or I guess actually our interaction factor. That whole collection is a factor. And then the other thing, staring us in the face there, this is our conversion factor. Okay. Now realize that the dependent variable's bottled up in the conversion factor. That's always true. I don't care what the conversion factor is. That's always the case. So keep that in mind as you move forward and try to discombobulate other mathematical entities. Well, we can start to simplify this, and the conventional symbol for the conversion factor in this electric force law, which has the name of Coulomb, we just like to condense that down to K, and then we do R squared. And the reason we can get away with that in this case is that R1 equals R2, which means we could just define it to be R. And in this case, we're dealing with magnitudes. And we can build this Coulomb Force Law as such.